Today we'll see most common pattern for the concurrency. That's what we use in a golang, and that's we're going to understand through small examples. So for that, let's understand this first, and this is part of golang for champion series. So you can also find another videos in a golang champion playlist over there. So let's understand this, and this pattern is most recommended pattern in a golang, and in other language also for the concurrency this can be used. Let's understand this in terms of golang. So there is a very small example. You do not worry about this commented code. I will highlight as it's needed, and once we understand the concept, it will be very easy. So concept is more important now. So in this example, there is a workload, or I can say the 40 is the number, and this 40 number, I'm checking all the numbers between from 1 to 40, and what are the prime numbers that, and I'll put that in a result, and I'll print that in a result from the result, and I'll check how long it takes. So n40, and if you see here, I'm running a loop. I is equal to 1 and I less than n, I plus plus, and if that number is prime, put that in a result, and check the total time taken for that, and print the result here. And the prime function is very easy. It's just check is prime. If the one is not prime, return false itself. If I is equal to, and then num divide by 2, whatever the number we pass, we'll run the loop and divide by 2, check is 0, return false, that means not a prime. If that number is not divisible by 2, at last you will return true. So this is a simple function that will check whether the number is prime or not. You can write your this function in your own way. Okay, so that's the small thing. Let me so once we run this for this, like 40, it will check. You will see the time taken here. This time taken is not even 1 second also. So yeah, this is the good for small number. What about if we increase the workload? So let me increase this workload to 100,000 and run it now. Yeah, so time taken for this, or let me yeah, anyway it's working, so I'll just comment this result, printing the result, and we'll see actual the time taken for calculating whether there's a number prime or not, and putting that in a result. So we'll see that time. It's running, so it's taking total time 1 second for 1 second for it's a 100,000. Yeah, it's for 100,000. Let's check for the 400,000. Okay, it's running, and this example, there is just a for 400,000 there is just one for loop, big for loop. There is a one process that's getting the one by one item, whether checking it's a prime or not, putting that in a result, and it has to do a lot of job. It has to process this, and it's taking like 26 seconds, and and that's a big number. Again, if the workload is higher, the number is again going to be higher. So for that, what we do, instead of this one for loop, what I'm going to do, I'm going to create one big pipe here. This pipe, in another language we say the queue, and in a golang we say the channel. So we create the big channel for the workload, and this is the workload channel. And this workload channel, we put all the workload like 400,000, And instead of this one for loop, I'm going to create a 1000 hectare. That is 1000 hectare is 1000 go routine, and in a Java we say the 1000 that's we can say threads, 1000 threads, but the go routine is lighter than thread. You can find the difference between thread and go routine. But anyway, here this 100 go routines are working on this channel, and this channel, what they do, they all of the they try to get the item one by one, all the unique item, and once the one actor or one go routine get the item, that item will be removed from the channel. So in this way, 1000 go routines parallelly, or we can say the concurrently, that's a better terminology. All the 1000 go routines concurrently get the data from this this channel, workload channel, and they all concurrently run the each prime, and once they get the result, they put that here in this result channel. So all the 1000 get the item and put that in a result channel. And there is a one additional go routine that will get the item one by one from here, from this channel, and put that in another variable result. And they keep doing this thing, and they will be busy of their work, and there will be wait. How long they will wait, this will decide, because once we put the load here, all the 1000 channels, we put the load and close this channel, and then so I'm just remember that term, close the channel. So put the things and close the channel. So that means all the 1000 will get the item one by one, and this channel is closed. So that means once this channel is empty, their job is done. Their job is done. That's empty, and they put the item here. But this actor will be just keep listening. Will keep listening from here. If anything here come, put that in another variable result. And if even though they are done, it's keep listening. But the thing is, once they are done, they have to, this actor has to also come out. And who will decide? So we'll add any one additional go routine, and what it checks, it keep checking that, okay, if once this channel is closed, then close this channel, and once this channel is closed, this will say that, okay, I'm done. So in this way, all go routines will be done. They come out, and the result we have already collected in a result variable. We can print that, and in this way it will be very faster. So the code will be a little bit longer, but once we have a clear understanding of the concept, you can replicate this concept in any kind of scenario for the concurrency in a Golang. So let's understand this. So first like we create this two channel, first one and this two. So one is for the workload channel, and this is the result channel. So let's create that. So for now, I'm just going to comment this code and unblock other code, and we'll understand this first. So in this code, if you see this block, whatever I have highlighted, so the first line, I'm saying, okay, I have created the workload channel, this channel, and the way to create the channel is make chan int, and what is the size of this channel? N. That's a workload size. So that's so big size of this channel. And this for loop, get item one by one from this workload and put that in a channel. So the 400,000 items will be stored in this big channel. We can adjust the size as per our requirement, but just we put that so big channels, we put their data here. And finally, once we put the data in this channel, we close this channel. So this term is very much important, the close the channel. So we close the channel. That means when this 1000 go routines, we get the item one by one process, eventually they will done once there is no item here. So, and that will be decided, and they will say that, okay, I'm done, there is no item. Once we close the channel, it will be clear message to them. So that's why we need to close the channel. Okay, so we created this channel, or we say queue, put the data over there. So this part of code does that. Now here we created another channel, result. This channel we created, and for this channel the size is just 1000. So this size, this is the less than this big. I'm putting the 1000 because there are 1000 go routines. They get that item, process here, put it here. We can also adjust that one, but yeah, for now I just put the 1000 items here. So the size is 1000, so the actors will be able to put the 1000 items. Okay, that's done. I'm creating one wait group. So in this way, all the actor will be waiting until unless they are done. And and here I created one go routine, this go routine, and this job is get the item from here and then put that in a result variable. So if you see, there is a for loop and getting the item from the result channel. So from here we get the item and put that in a result variable. Again, we will be surprised here, like why we are, even though this like we are not putting anything here now. So this actor or this go routines are not ready, but we put this thread and listening here. That's fine, because this channel is, the result channel is not closed, so just listening. If there is no item, keep waiting. So this this go routine, so go func I put, and this go routine will just waiting, and if there is some item comes in a result channel, get it from there and put it in a result. So this is not like a normal for loop. This is we are running this for on channel, and this will be blocked here. Like if there is no item, then it will be waiting here, so it will just keep waiting and put the item, then get the item from the result channel and put that in a result variable. I added in a wait group because this is the one go routine, and here I am saying done. So sometime defer will run at the end. Once this for loop is done, it will come out and it will say okay, I'm done. So this is another one go routine. Now the next thing is I'm going to create this 1000 go routines. This 1000 go routines get the data one by one, like from here. So if I say the one by one actor get one by one, another actor one by one. So they are actually clone. They run concurrently. And they all hit this workload channel and get the data and start processing and put that here. So for that, I'm running one for loop for 1 to 1000, and there is a go func. So the go func is a go routine. So in a loop we are creating 1000 go routines here, and for the 1000 go routines we added one by one. So that means we added 1000 go routines in wait group, and all the thousands are cloned. They run independently, and once they are done, they say done, so it will get removed from WG wait group. And their job is their job is again get the data from workload from this and check whether that's a prime or not, and if it is a prime, put that in this result channel. So they run concurrently. 1000 clone run separately, and this is the for loop. That means until that means as long as there is a data, it will, this thread or this go routine will get the data from this workload. Okay, so this will again busy, there will be all the 1000 threads or go routines will be busy getting the data from here, processing, checking is a prime or not, and put that in a result channel. Now we have to write another go routine that will check whether this is done or not, if there is any item exists here or not. If no item, then close this channel and come out. So here I have put the wait group. So there is another go routine, and in this case I have the infinite for loop. I am waiting for 200 milliseconds and checking workload is 0 or not, because they will get the item one by one. Sometimes it will become 0, and once it is 0, close the result channel. So that's why this actor job is done. So this actor job, the first we wrote, this actor is done, and then come break, and then there's a WG wait. So in order to come out from this work wait, all the threads need to be completed. So for this, anyway, these thousands will be done by themselves, because this channel is closed, and they will just keep getting the data from here. And there is a for loop workload ch. So once this data, there is no data in this, they will automatically, they will be done, because we have already closed the channel. So the thousands will be closed. So but in a wait group, still still this one is for the result. This thread, this actor will be still busy, so they will not come out from the wait group until unless we close this channel, because this actor is listening on this channel. So we need to close this. So here we have the logic. Once the workload, this is length is 0, then close result channel and break and come out of this for loop. So this go routine will be also done, and this channel is closed. So that means this go routine at the first, whatever we have written, that's also done. And finally we have already collected the result, and we have already put that result in the result variable, and come out from wait, and then just print the time taken, and it will print the result. So first print the result for a smaller number, and then we'll remove and again run to see the time taken. So anyway, for now I'm just running for 400 items. Save it. Undefined sync. Save it again. Okay, we see the item here. Here, and the time taken is not even the second also. Okay, that's good. Let me increase this 400,000. We'll comment this print, save it. Let's make sure again it's 400,000. It's 400,000, and run this time one second to see the time. Yeah, it's very faster. It's almost like 3 seconds, 2.9. So almost 3 seconds. In 3 seconds compared to the 21 or 26 in the previous run, it's very faster. So this is the pattern, like we need to understand clearly, and we have to make sure when we come out of this from the wait group, we have to make sure all the channels have got closed properly. And yeah, so you can try this, and then this pattern can be utilized in any concurrency problem. So that's the whole code here. It's not fitting in one, but yeah, you got the idea. Okay, that's all for now. Thank you.